Hi, my name is Luisa Ramirez, and I'm doing part C for our project 2, which is laminar flow over a flat plate. So our first step here is going to be to drag over fluid flow, right there, and I'm going to right click on here and use design modeler. Gonna wait for that to load. Might take forever, that's okay. Alright, and we're going to do a 2D shape, so just focusing on Z here. We should click on that, sketching, and we're just going to do a simple like a rectangle here. I want to zoom in a little bit actually. Then I'm going to go into dimensions, and we are given our length. It's going to be 1 meter. And yeah, I did draw it really big. It's okay. Okay, now we're going to do our height, and I just chose to do my height at like half a meter, so 3.5. What happened? Oh, I changed the wrong thing, sorry. There you go. Okay, then we're just going to go back into modeling. I'm going to click this, then concept, surface, some sketches, sketch 1. Apply, then we're just gonna generate. There you go. Now you have our shape here. Nothing too crazy. I'm gonna close out of this. Now, I do have the check mark there, but I'm just gonna update it just in case. And now we're gonna go into our mesh. You can just double click on that. Wait for that to load a little bit. Okay, just let it do its thing. Alright, again, focus again on our 2D face. And what I like to do first is just like name my edges. So I'm gonna call this the far field. Okay, this one. Going to close our plates. The left is going to be our inlet, and then the right is going to be our outlet. And then you just click and hit N, then that little menu should pop up. And then I'm going to forget to name our surface. This is going to be our airflow. Alright, and you can see here, it's all the name. Alright, and then I'm going to create a mesh, and see, I'm just going to do a face meshing. It's going to go on our airflow. I'm going to click right there in the middle. Okay, yeah. Apply. Not changing too much here, it's just going to be that. And then going back to our mesh. Now we can do our sizing. And we'll start with our upper and lower bounds. I'm going to make sure I'm on edge click, and our far field, and then control click our plate. Hit apply on there. Okay, and here we're actually going to change something. Instead of element size, we're going to do number of divisions. We want a kind of like a finer mesh, so we're going to hit 50 on there, and then capture curvature to no, so we can set our behavior to hard. Yep. And then going to go back into our meshing and make another mesh sizing. And now we're going to just clean for meshing at the inlet with another one. Hit here, apply, and then number of divisions, 60. I want it to be a lot finer here. And we're going to hit no. This hard, of course. And then we're actually going to set a bias here. So I'm just going to click this top option, and then this little menu should pop up. And our bias factor, we're going to change that to 70. Alright, that should be all updated. We're actually going to do the same thing for our outlet. Not actually the same thing, but I mean pretty much the same thing. Alright, dimensions, 60. Curvature, no. Set that to a hard. Then our bias once again. And then we can set that also to 70. But we are going to do a reverse bias, and it's going to be at the outlet. Just hit apply on there, get one edge. So it should look like this. And then with our meshing done, we can go here and then hit generate. Let that do its thing. And then you see it should be a lot finer at the plate here. And then it can get a little bit bigger, oops, as it goes up to the far field. There you go. Not super crazy. That's pretty much it. You can close out of that now. Alright, now in our setup, I'm gonna go ahead and edit that. Oh, I actually forgot to update this, so well, let me see if we can update it now. Something crazy might happen here. It's not really showing me what's happening, but at least this is happening. This is what we want. Alright. Okay, yeah, so that did update first, and then now we're going to our setup, I think. Yes. Really shouldn't be taking this long, but okay. I'm just scared to click into it again. What if I... Hello? I hope this isn't too long. Okay, still starting fluent. Not seeing it though. Oh, wait, it's right here. Okay, guys, sorry. That's my fault. Shh, it's okay. Alright. Alright, still waiting for that to load. Should say done around here when it's ready. Let's redo this. Okay, looks good. Alright. Done, 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 done. Okay. Alright, so here's our airflow field. We have our inlet. You see we have a lot of arrows going down here. Then a lot of arrows here in our outlet. Okay, so everything right here looks good. Pressure base, of course. So first, I just want to choose our material. Alright, so just keep things simple. We are told to use a 1.2 density, and then we're just going to round this up, our viscosity up to 1.8. Change, and then close. And then I actually did this error the first time I was doing this. We want to change our reference values, and we're computing from the inlet. So here we go. Make sure this is all set. And I don't know, the last time I was doing this, it just did not update for some reason. There you go. Alright, so now we're gonna go to our models, make sure we're in laminar. Oh. Okay, so that's not what I wanted. I'm gonna go to model and then laminar here. And it should update like that. So I'm just gonna collapse this again. And now we're gonna want to set our boundary conditions. So first go to our inlet. And then we are going to be using a velocity magnitude of 2. Apply on there. Everything else looks good. And then... Alright, and that we're just going to make sure our plate conditions are set. Dot fluid. And it should be stationary with no slip. Looks good. Everything else should be fine. And then for our far field, we're actually gonna wait for that to load. Alright. Is an option to change this from wall to symmetry. There you go. So you're just gonna right click it, go into type, then hit symmetry. There we go. And it should come away from the wall. So we have our inlet, outlet, far field, and plate all set up. And basically change it from symmetry to from a wall allows the far field to behave similarly to the plate below. So there we go. Now I'm just gonna go into solutions. Just click on this. Oh no. Methods. Yeah. Just gonna change it from simple. Okay. And then go down to monitors. Residual. Then we're just gonna add a couple zeros here. Just 2 more zeros. Should be fine. Alright, okay. And now this is the easiest step. Initialization. Okay, standard. And then we are gonna compute from our inlet. And then just make sure everything looks okay here. We're just gonna change our y velocity back to 0 because we only want x velocity. Okay, so we have x velocity 2 and y velocity 0. Alright. And then I guess we use it initialize for that to go. Oh, is that all set? Okay. Alright, with that done, we can run our calculations. Yeah, just so we have like enough data, I like to do 10,000. Go. Then nothing else really needs to change. We're gonna hit calculate. Should zero plot, yeah. It's gonna shoot up and then they should converge all together down here. Looks nice. Alright, calculation complete. Now our final step for our plots, we can go over here. Click. Alright. And since we do want our wall fluxes, we want wall shear, and then you're going to see skin coefficient over here as well. And we're going to be writing from our plate. So order points and then write to file. Write to file, you're going to get like I'll just show you. Okay, so we're just going to hit write, and then you'd also hit write right here. But I already have these. So here's my skin friction. It's basically what it gives you. Here's our x, and then our skin friction, of course, like the position, and then what it is. And I also have my wall shear stress. And I can show you my Excel sheet. I actually copy pasted all these values over here, and then with my simulated, I did my theoretical. Here's my equation. I just did like the if error because this was giving me trouble. Since we're divided by 0, it was kind of getting angry at me. But as you can see over here, it fixes itself. So we have 0.664 over our Reynolds number. That's square rooted, of course. And then you can go all the way down for all of our position values. And then I did the same for our wall shear stress. Just copy pasted over here. Same values, you know. And then my equation over here was this big equation that is given in our report. I'll show you that as well. There we go. Here's this equation. Oh, kind of big, but that's okay. There's nothing too crazy. So yeah. And then I also did my graphs down here. As you can see, they're pretty similar. It's because they're like kind of the same thing, just shown with different, you know, equations. Not really the same thing, but they're kind of the same thing. There you go. Then I can also show you my percentage error. Here we go. I did just find like the middle of them because as you can see in my Excel sheet, it just goes around the values we evaluated. So 34, 36, I just added those two together and then divided it. So you can see it's here. And then it's pretty similar to my theoretical, although my theoretical of course has a lot more like decimal places to it, but that's okay. They came out to pretty much the same thing. not pretty much, okay, 5% is a big error, but it'll do for our purposes. So there you go. And yeah, just click on your columns and make your charts. I just compare them here. Might be a little bit blurry for some reason, but there you go. You see all the little points there. That's pretty much it. Not a lot to it. Okay, so thank you.